Welcome! Today we're going to learn integration of a definite integral with absolute value. So let's begin with an absolute value function, which you see in 1, absolute value of x. And I want to show you how you can rewrite that function without the absolute value sign. And the way to do that is to use what we call a piecewise function. So if you go to 2, you'll see what we have done is we've kind of broken this into two parts or two pieces. Basically, as you know with absolute value, if you put a number in there, the result is always positive. So in the case, there's really two cases that we're dealing with. One, if x is negative or less than 0, then when we take the absolute value, we have a positive answer. So if we get rid of the absolute value signs, we still get the same result by just writing it as negative x. Think of it as if x is negative, then you've now negated again, and then you'll get a positive result. The other case is when you have a positive value. If you have x as a positive value, there's really no issue because obviously when you get the absolute value of that, it'll be the same. So in that case, we really don't have to do anything to our function. We'll keep it the same. Now, just to clarify it a little more, if you're not completely getting this, in item 3, I want to give you a specific number to look at it. For example, let's just say x is less than 0. So let's choose, let's just say x equals negative 2. Okay, so if we plug into the absolute value function, the result is positive 2. But again, if we don't have that and we want to display that in some other manner with that absolute value sign, what we're going to do is just take the negative of that x value. And the negative of negative 2 will give us the correct answer, a positive answer. The other case, again, if x is greater than 0, we're positive. So let's choose 2, for example. In that case, there's really no issue because of the absolute value of 2 is a positive 2, and x is positive 2. So we really don't have to do anything to our function. But the key thing here is if you want to rewrite your absolute value function where we're not using that symbol, you need to split it up into two parts to handle both cases, one when it's negative and one when it's positive. Now, the reason we're doing all this, or I'm telling you all this, is because what we're really trying to do here is integrate with a definite integral, but where the function is an absolute value function. Okay, so that's what we have in item 1. So what we're going to do is, in this particular case, our absolute value function is x minus 6. So we're going to use the same rules that I just showed you earlier to split that up into two parts. The case when the result inside the absolute value signs is negative, and the case where it's positive. So when would what's inside the absolute value sign be negative? Well, it would be when x is less than 6, right? If x is smaller than 6, we're going to get a negative result inside the absolute value sign. So that's case number 1. The other case is when x is greater or equal to 6. Now, when we look at this, how do, it's kind of obvious. Sometimes the function may be a little more difficult. So the easy way to do this is just whatever's inside the absolute value sign, set it equal to 0 and solve for x. Whatever that number is, that's the number that we're going to split it up under. And in this case, it's 6. Okay. Now, the first scenario, if you have a negative result, what are we going to do? We'll negate the function, and that's what you see in the first part of our piecewise function in item 2. In the second scenario, we have a positive result, and then there's really nothing we have to do with our function, so we keep the original function. Okay, so those are the two scenarios. Now, we're going to utilize this to rewrite our integral using this concept and removing the absolute value signs. So if you look at item 3, we have split up our limits. Recall in item 1 that our limit goes from 0 to 7. But I told you that at 6, we kind of are going to have two particular scenarios, one when it's less than 6, one when it's greater. So instead of going from 0 to 7, what we're going to do is go from 0 to 6 and then from 6 to 7 because each case is different. So we've done that in item 3. And you've noticed that when we're dealing with something less than 6 or between 0 and 6, we have the negative of our function here. When you have the case, and you see that in A. In the case in which we go from 6 to 7, and x, now we have a positive result, we just have our normal function, which in our case was x minus 6, and you can see that in B. So all we've done is split up our integral. Okay, so I've rewritten our integral in 1. In 2, we actually do the integral. At this point, very straightforward integral. Don't forget you do want to distribute the negative. Okay, so now it's really negative x plus 6. And then we're going to use basic power rule here. And our limits in our first integral go from 0 to 6. The second integral, same situation, basic power rule, but we go from 6 to 7. In item 3, we actually plug in our limits. Now recall, using the fundamental theorem of calculus, we use our top limit first. So that's x equals 6. And in A, we just replace x with that. That's all we do. Then you subtract. And then in B, we use the bottom limit, which was 0. And when you put 0 in, everything turns to 0. So it works out nicely. In C, now we're dealing with our second integral. The top limit in our second integral is 7. So we replace x with 7. And then in D, we replace x with 6 because that's our bottom limit in the second integral. Again, you put all that together and you simplify, add a bunch of numbers. Hopefully you know how to do the whole common denominator thing. And in 4, after simplifying, you get our answer, which is 111 over 2. And that is integration of a definite integral with absolute value. Now go practice, practice, and practice some more.